This video shows a robot in an unknown dynamic environment. The goal is for the robot to learn the static dynamic structure of the environment and shape its path in order to perform a persistent sensing task in the dynamic regions. These dynamic regions are represented by a grid of purple dots. The green quadrotor and the green circle represent the robot and the robot sensor footprint. The black line represents the robot's path, and the purple dots represent the points of interest or dynamic regions of the environment. The robot initially travels its path without reshaping it in order to sample and learn the static dynamic structure of the environment. On the right, you see the rates at which the environment changes, and as the robot travels its path and samples the environment, its estimates of these rates converges to the true values. Once the robot learns where the dynamic regions are and the rates of these dynamic regions, it reshapes its path in order to cover them and improve the stability margin of the persistent sensing task. Such a path is called an informative path for persistent sensing. What you are seeing now is the robot using our design controller in order to shape its path to cover the dynamic regions of the environment, which are represented by the purple dots. The plots on the right show the stability margin of the persistent sensing task being locally maximized and our Lyapunov-like function being locally minimized by the action of our controller. The final path generated by our controller is an informative path that locally optimizes the persistent sensing task.